I would want to start in about 2 minutes. So I would request that you contact your colleagues, side chat them, and just let them know that it's important that they attend this class and subsequent ones. So please, if you could just notify those who are still not in the session to quickly join. I'll begin in 2 minutes. Thank you. All right. So I think we'll begin. Let me take this opportunity again just to welcome you to this semester's 512, and that is industrial automation as part of control engineering. Now, this semester, we have a very interesting topic or very interesting discussion around automation, and that's why this unit is basically referred to as industrial automation. It's very, very specific to certain control systems. Now, let me share my screen. Just a minute. Thank you. So I'll just begin with a few briefings regarding this unit and the course outline, and then we can do an introductory class in a few minutes because we just have a 1-hour class. Now, this unit would require you to make use of a lot of what you discussed in fourth year control systems, that is 402. So one of the prerequisites, of course, really the main one is, I think this was taught by, if I'm not wrong, is Mr. Faris. This is FEE512. The idea that we want to, or the main purpose for this course this semester is just to introduce to you the application area of control systems, but specifically in industrial automation. So our scope here is simply to design. This is basically the objective that we have to achieve. Let me just say develop programming, logic controllers, I think I should say the better term is to use develop programming techniques and then analyze and design PLCs. So we'll need to develop efficient PLC programs. We'll need to design the controllers for given industrial processes. So we'll have several examples that we'll look at. I will, of course, share with the class rep the course outline, the detailed course outline with the other recommended material. So, but basically, our course outline this semester is just to discuss one thing, but it's very detailed. So the first thing that we'll need to start by doing is just to have an overview of PLCs. Okay. So once we have a clear, this includes the operational principles of PLCs. I'm sure by now you've met PLCs, at least in the fourth year labs. We'll look at some of the internal architecture of PLCs, the various brands that exist, the softwares that exist, and so on and so forth. But again, we'll also need to look at the basic ladder programming, very important. So again, by now you should have at least involved yourself in a little bit of basic programming using PLCs, especially for those who made sure that they did something in the control lab. And then we'll move further ahead to do data handling instructions, still around PLCs. How do we handle data while using PLCs? So data handling instructions. Okay. Then we look at other types of instructions that are very common to PLCs, and those are timer and counter instructions. Okay. Again, you might have met a few of these, but now we'll go into detail where we look at what are some of the timer instructions that exist. You know, the on delay timers, the off delay timers, the retentive timers. How do we cascade these timers for several application areas? Then we look at the up-down counters and how do we also cascade counters. We'll even go further ahead and look at some of the shift register instructions. Then we look at the program control instructions, also critical program control instructions. So in program control instructions, this is where in PLCs we have two, not really two, but quite a number of control instructions that are very important that control the ladder diagram, and that is the master control and the zone control, the jump instructions, and even the subroutines, you know, the interrupts, the temporary end instructions, and so on. So we'll just look at some of those and how we apply them in in PLCs. And then if we have time, of course, we have to create time for, because this is basically the end product system design, where you basically can design your own PLC controller for a particular industrial process. In the labs, for example, we were designing a PLC controller for, you know, to control the traffic lights in a four-way junction. That's an application area. You can design PLCs for temperature control, you know, for how to sequence valves. Maybe if you're working for, you know, Kenya Pipeline Corporation, how do they sequence their valves? For conveyor belts, how do we control, you know, velocity? You know, all these are system design problems that we can apply PLCs to. So at the end of our discussion this semester, we should be able to handle any industrial processes and probably have certain design around their controls using PLCs. Now, you are final year students, and you're basically almost on your way out to being engineers in the field. You will realize that in the world that we live in today, automation drives everything. And so this is a very, very important subject for you. It never existed in our time, but over the years, automation, especially industrial level automation, has become a very, very key block in driving our economies and driving development and manufacturing. And so a lot of the principles that we are going to discuss today will be applicable, almost certainly applicable in all industries that you will visit, especially those that has very high productivity or deal with fast moving consumer goods and so on and so forth. So it's very, very critical that we take time to understand most of these processes. Now, a lot of this also should not just be abstract information. A lot of this information should be made as practical as possible. We should be able to see how what we learn in class can actually be applied in real life and help solve problems that we have out there. Okay. Now, again, I would not want to indicate here because I don't like restricting students to specific books, but there are quite a number of books today that exist both in the library, in the bookshop, or even online that deal with industrial automation. However, like you might have guessed, our class book that I will base my discussion on, I provided this in fourth year, is Programmable Logic Controllers. Programmable Logic Controllers. I'll give you the course outline, and so you can pick some of the books that I indicated there as well. But the book that I'm really interested in is the book by Frank D. Petruzella. I think it's double L, something like that. And it's a McGraw-Hill production or a publication, McGraw-Hill publication. And it's best if you have one of the latest editions. I don't know whether it's now on the 5th or 6th edition. Please get the latest edition because usually they improve the material, they improve the questions, they provide solutions, they work out more problems and so on. And so get the latest edition that you can lay your hands on. It's a very, very, very good book, self-explanatory, and it is diverse. It will provide you with a lot of application areas. The illustrations there are wonderful, and you'll enjoy reading that book. So basically, this is what we are supposed to cover this semester. Now, being that this is sort of like a continuation of what we were doing last time in the last semester, it's important that you understand the nitty-gritty. You know, we'll have an exam, which is 70%. You know that we'll have at least one CAT, but we'll also have quite a number of tutorials that I'll provide you with, and maybe homework or assignments that also contribute towards the final mark that you obtain at the end of this semester. So I encourage you to take this seriously. Over and above this, I told you I was impressed last semester that most of you attended at least 70% of the classes. I would want to encourage all of you to make sure you attend all the classes, unless it's absolutely necessary that you don't attend, because we are human beings and we encounter a lot of things in life. And so in one way or another, you may not be able to attend one or two classes, but purpose to attend all the classes so that you don't miss out on what the discussions are about. Very, very critical that you gather as much information as possible. And I also would want to learn more with you guys regarding industrial automation. Okay, so I hope that is clear. As usual, if you have any queries or any trouble that you'd want me to help in regarding this unit, please, you know my email is igevira@uonbi.ac.ke. Now at UON, fortunate to have two offices. One is at the Institute of Nuclear Science, room 32. The other one is at the American Wing, 305, right? So you can always consult during the sessions between 8 to 5 when I'm available. But I would highly encourage you to reach me out on email first. And if it's something that requires a one-on-one interaction, then we can, of course, meet in any of these rooms. Now, as usual, again, we'll have a hybrid session where we have both the physical classes and the virtual classes. There are certain areas that I'll need to illustrate or play a video here and there or do some illustrations regarding PLCs. So most of this class will tend towards the PLCs. I mean the online, the virtual one, because we can illustrate a lot of material virtually, especially when we get to the softwares. It's very difficult for me to illustrate anything physically when we're in class on the softwares that we use in PLCs and how we do design. A lot of this requires demonstration. And so an online class would be preferable to demonstrate some of the things that we need to showcase this semester. So, but we will make sure that we also have a blended system. So we'll have both the physical and the virtual classes. So please just make sure whether the class is virtual or physical, make sure you purpose to attend. It will be very, very, very helpful. All right, so that is the first part of my discussion. 20 minutes. Then now we can move on to the gist of the matter, because we missed a class on Monday. And so it would be difficult to recover that. So we have to make good use of all the time that we have. So I want to introduce the session today. So basically, unless there's any question outside our formal discussion, you can ask, or we continue. But I want to begin on industrial automation. You guys now know how to deal with me. You're supposed to be taking notes. I'll also try from my end to send you a few notes here and there. But a lot of the stuff that we might get into might not be available in the notes. So you should be taking a few notes here and there. But again, also, I'll try and provide as much material as possible. I have also given you the class book that we'll be using. So you should also use that as a supplementary material for your own personal reading. Very, very important. Anyway, so I would want to begin. I am actually just speaking, hoping that you can hear me. I'm not even sure if any of you has been hearing me. Please, can I just get a feedback that we are together?
Yes.
All right, thank you very much. Okay. So let me continue now to the gist of the matter. Ladies and gentlemen, imagine a factory where we have machines that work tirelessly. They work 24/7. There are no breaks. There are no errors. There's no fatigue involved. Where you are having products that are being assembled with precision. There's a lot of quality involved. And that quality is consistent. I mean, consistently high, and even the production lines adapt instantly to changes in demand. If the demand is high, the production line ramps up. If the demand is low, the production line slows down automatically without human intervention. I know sometimes it might sound like science fiction, but that is the world of industrial automation. That is powered by what we usually say is the unsung hero of modern manufacturing. And the unsung hero here is the PLCs, the programmable logic controller. So what is industrial automation? What is this? What is industrial automation? So in a nutshell, industrial automation is basically the use of control systems. So you see, we cannot escape from control systems. It's the use of control systems. And these control systems could be computers. So let me say, such as computers. They could be robots, so control systems. And basically PLCs, let me just say PLCs, because that covers a lot of other controllers. And we use them to handle, and this is very important, industrial processes. Industrial processes. And sometimes machinery, because sometimes you want to handle or operate machinery. But you want to do this with, I don't want to say without, let me say with minimal human intervention. minimal human intervention. You guys have gone for industrial visits, and when you go to this, maybe you've gone to Kipevu 1 or Kipevu 2 or whichever, you will see that a lot of the machinery operates automatically, meaning that there is very little human intervention because of the very nature of this equipment. Some of the conditions are very dry, some are very hot, some are, are very risky because they are moving parts and they are sharp and stuff like that. So human beings really do not need to interact with those equipment or those machines in a close proximity. So they control them from afar. So industrial automation is about making industries smarter, faster, and actually more efficient. And because all you want is profitability. So you want to produce with the minimum cost of production, but you produce the maximum product, but they are quality products and you do it consistently. So that is why industrial automation comes in. Now, for somebody who may ask that, then what is the difference between automation and mechanization? One, let me just indicate that automation can be achieved. I won't write much. I just need you to listen. But we can achieve this by scientific techniques. Scientific techniques or scientific approaches. Let me just say scientific approaches. Okay. And those approaches could be mechanical approaches, where you've got mechanical parts. You can use hydraulic parts. You know, if you are actually paving a road, you have those big moving machines, you know, that are hydraulic. You might need electrical, an electrical approach. But let me just add an electronic, because usually they tend to go together. Okay. You have other approaches that pneumatic, using compressed air, or you can use computers. Though that's approach to solve a problem of automation. You can use computers. Okay. But you will find that in most cases, the best automation tries to combine all this. So you can use this in combination. So all these approaches can help drive automation. But it is not mechanization. You see, mechanization is the use of machinery or powered machinery to help a human operator. Okay? I'll give you an example. If you go to Kericho, where they are plucking the tea, initially they were doing it manually. So human beings would pluck the tea leaves manually. Some of them still do it. However, they brought this machine that would help pluck the tea leaves. There was a lot of political, contest around it. People were saying, oh, they're going to replace humans. But if you look at it, the machines are supposed to help the human operator to achieve the task, in this case, to pluck the tea leaves. So what it simply is doing, it is replacing human power and providing machine power. So mechanization is basically mechanization is to replace human power. Focus power with machine power. This is not automation at all. It is simply replacing human power with machine power. Okay? It simply is displacing labor. You're trying to displace the physical labor that we provide. Automation, like I've told you, is meant to replace, or let me say, this is meant to displace mental labor. This one displaces physical labor. Okay? Very, very important. So there's a very big difference between mechanization and industrial automation. Okay? So industrial automation is meant to achieve high production efficiently and with speed, but to replace the mental labor that would otherwise be involved in that. And it is a combination of different processes or approaches. It could be mechanical, hydraulic, electrical, pneumatic, and all that, all combined together through specialized equipment to make sure that you aid in your production, manufacturing, helps with quality control, help with handling of processes, and so on. Okay? Now, in the world we live in today, automation is all over the place. The supply chain that exists around manufacturing is driven by automation. It is very, very difficult to walk into a factory today or a production line and find that they are still using manual processes. They're usually these days technologies that help and I mean technologies and tools that help drive that process, which is automation. So it's important for us as engineers to adapt, to change with the times or to catch up with the technologies that exist today and see how we can continue to use some of the skills and some of the principles that we learn in control systems in order to build systems that drive automation. And with that, there is efficiency, there is speed that is achieved, and you provide, you save on a lot of costs that you'd otherwise have to use. So basically, what we are saying that automation has a lot of advantages. Okay, one, most of the companies, obviously, if you speak to the CEOs or those technical officers and stuff like that, one of the biggest drivers of embracing automation is to increase productivity. So this is one of the key reasons why they automate their systems, because they want to increase productivity to meet the market demand. And of course, that comes with a benefit, which is the profits that they get. You'd want to minimize fatigue, minimize human fatigue. Notice, fatigue is not a physical problem. Fatigue is a mental problem. Whenever you feel that you're tired, the brain basically is worked up, okay? Because the muscles could work day and night until they tear apart. But it is the brain that controls it based on the availability of energy in your body. So to minimize human fatigue, because a lot of industrial processes are repetitive processes. You're doing something in a repetitive manner and you want to do it very fast and you want to do it over a long period of time. So to minimize human beings doing that, because human beings get tired very fast. For example, if you're driving a truck and you want to supply products between Nairobi and Kinshasa, you see, a human being can only drive for 8 hours, after which their levels of concentration or fatigue sets in. So they'll not be able to achieve much. So they're expected to stop, rest for at least 6 hours, and then proceed. But with robots or with automated systems, these systems can run for years without stopping. For years without stopping, and there's no fatigue. The level of efficiency will be maintained, the quality of the products will be maintained for years without stopping. And that's why automation becomes a very, very important thing. The other thing is, you can imagine in an industrial or in an industry setup, if you're hiring manual labor, the more work you have, the more manual laborers you would need. So that definitely means that you'll require a lot of space to accommodate these guys to work in that area. But when you have automated systems, so you have a packing machine, all the products that come, it packs automatically. It will, of course, occupy a less area, less floor area required. Okay, because these systems occupy very little space, and once they are fixed, they're able to operate or do a large amount of work without having to occupy a large space. As we shall continue learning, I'm tired of writing, but as we shall continue learning, you'll notice that a lot of these PLCs, which I told you are the unsung heroes of automation, they don't require much maintenance. They are built to work in very, very, very tough conditions, and they do that with very minimal maintenance requirements. That's an advantage. Okay. You'll have an effective control over production, that we've said. The quality of your product will improve and will be consistent, that we have also said. And there's so many advantages that I would not put down here in one class. But I want us to understand that, like I said before, you will find solutions, industrial automation solutions, all over the place. Whether you are handling materials, whether you're packaging materials, whether you're assembling systems, whether you need convey systems, moving them from one place to another, whether you're doing machining, you would not make washers with a file and cut them in those I would want to say very, very archaic techniques that we used to do in first year. There are better methods that are more refined and are safer, and they produce better results. So whether you're doing those fabrications, whether you're doing painting, whether you're doing quality control inspection, if you're working with quality control and you're sent in a production line where there are 10,000 bottles of soda being produced every hour, and you have to look at each one of them to make sure they meet quality standards, you'll be tired, and you'll need a lot of personnel to be able to keep the quality levels in check. But if you have an automated system, which will use PLCs, that is solved. And you can run as many bottles as you want, increase the speed, do whatever it is you want, and still you get the same quality control and inspection. So that's where, it's important we have this. The industrial robots that are coming up, you can see that with AI, which again is part of PLCs, you'll see that AI is helping us to build robots that are able to do much more than they could before. A lot of this automation, all PLCs are used in food and beverages. I told you, fast moving consumer goods. So go to Coca-Cola, go to, how do they call it? Kenya Breweries, go to Brookside, go to all these companies that deal with fast moving consumer goods. Unilever, I don't know whether they exist anymore, but all these companies make use of these automated systems. For those who are doing civil engineering, when you go for drilling, when you go for excavations, those who are doing sewage systems, those who are doing, conditioning of equipment, a lot of areas that automation is applied today. And so it's a very, very interesting area. But again, the biggest question would be, why PLCs? We have said the reason why we need automation is to achieve three key things. I don't know whether I indicated it here. Automation helps us to achieve, like I said, smart systems, faster systems, and more efficient systems. But why specifically PLCs? Are there not other control techniques that we can use to achieve automation? Why do we pick PLCs? So we've agreed that at the heart of industrial automation is PLCs. But PLCs, the best way that I usually define PLCs is PLCs are just rugged, reliable, programmable devices that act as the brain of modern manufacturing systems. Okay, and they are very important because they will control the machinery and processes. They will handle the complex logic operations. They will operate in very harsh conditions and environments, whether it's dust, heat, vibrations, whether it's underwater, whether it's in space, all that. And they will also be able to communicate with other systems. Because in this day and age, communication is very important. So these PLCs are able to communicate with SCADA systems, and SCADA systems are partly made of PLCs. SCADA stands for Supervisory Control and Data Acquisition. They'll communicate with IoT devices, Internet of Things, and they'll communicate with the cloud platforms where we apparently store most of our data today. So PLCs are very diverse in their operations. So in smart manufacturing, you find PLCs. In automotive assembly lines, you will find PLCs. In food and beverage industries, you will find PLCs. In areas where we need energy management, these days people are big on renewable energy systems, wind farms, turbines, how do you adjust those blades? So part of your visits usually is to go to, it's called Ngong Windmills, if I still remember. I don't know whether you went to Ngong Windmill. They have, you can look at if you can see the blades, the turbine blades that are there, they're so huge. How do you adjust them? You can't do that manually. PLCs will be able to do that. And because you can really, if you remember, for those who went to Ngong Windmills, they say that those turbines, the blades are at an angle for a certain reason, and they help a lot for wind speed and direction to ensure that you have your maximum energy output. So how do you adjust them to the correct angle and direction so that you achieve the right speed? That's optimizing. That's what I mean. You use PLCs, okay? Water treatment plants, all these water treatment plants that we have, sewerage treatment plants, all these require PLCs, okay? So that's why it's what PLCs are. But so why are they important? Why should you care to pursue anything that deals with PLCs? I can assure you that there are a lot of career opportunities around PLCs. So they provide career opportunities. Let me just say, why care? Provide career opportunities. There are people who make their money out of this. I was telling a few students that I was lucky some time back to have gone to study. My PLCs were not offered as a course, or any training was not offered in any institution in Kenya. And a lot of the PLCs that exist in the Kenyan industry are made by Siemens. And so we had to travel to Germany to learn those. So companies would sponsor their employees to go and study PLCs and then come back. So I once was lucky to get that opportunity, and then later when we returned with a lot of other friends, they went to do things all over the place. I remember there was a time that I was employed by Tetra Pak. I don't know whether it's still in industrial area, but basically they deal with packaging solutions for almost all these packaging things that require packaging, whether it's juice or milk or whatever. And then I left that place, and then there was a problem with, it was called, there's a company called Coca-Cola Juices Company. It used to, there was a name for it before, because where Coca-Cola used to make their sodas in one plant in Nairobi, they call it Nairobi Bottlers, but then the juices, the ones that are called Minute Maid, were made in a different company. They were called Beverage Services Kenya Limited, something like that. They were trading as Beverage Services, and they had this one line that they were using to produce the juices, and that line went down for a whole week, and it was something to do with the PLCs, and they couldn't understand what exactly. The engineers there could not figure out what the problem was, so they were advised to hire. To get the owners, the PLC manufacturer, to come and look at the system. And the PLC manufacturer was not non-committal. They were very busy, so there was no one who was willing to travel all the way from Germany to come and look at the system. And so I think one of my acquaintances advised them to call and ask if I could help. And so one Sunday I was asked to go there, and I was apparently in my rural home. So I told them I would not be able to get there in time because I was very far away. I was shocked. They sent me a chopper to come pick me up. That is how important it was for them to have the line working. And when I went there, actually, I simply, because of the training that I had, I was able to look at the system and then troubleshoot it. And so the knowing that, having that knowledge of the PLCs helped me a lot to help them solve the problem. And they were running after a few hours, of course. And of course, the remuneration is not bad. So basically, you can form a career out of these PLCs, especially in today's world of automation. The reason we should also care about PLCs is they're very efficient and they're sustainable. I told you they require very little maintenance. So efficiency is one key thing about PLCs. They're very, very efficient. And maybe let me add sustainability. And, you know, in a world where we endeavor to reduce waste, we endeavor to save energy, we endeavor to boost productivity and make industries more sustainable. Okay, people are going green. PLCs really are an enabler to that endeavor. So it's very, very important. Of course, PLC is a very innovative process. So it's actually, I would dare say that PLCs, programmable logic controllers, are the backbone of all these emerging technologies, IoT, AI, smart factories, whatever it is. They are based on PLCs. Okay? I've just remembered a fun fact. Let me write. Fun fact. The PLCs were, for those who want to know a bit of history, they were developed in the 60s. So it's not a very old technology. It's very new. 60s is just 60 years ago. Most of the technologies we use today were built centuries ago, but this is just 60-year-old. But they were first developed by General Motors. You guys know that General Motors, let me just say, built in the 1960s. General Motors, of course, you know, they assemble motor vehicles, and they had these relay systems. Again, we used to take students to what we call ex-telcoms building. I don't know whether it happens these days for those who take the light current. We used to be taken to ex-telcoms building. It's just behind Posta. And in ex-telcoms building, that's where they used to house all the relay systems for all the communication in the country. So Safaricom had to relay from there, Posta had to relay from there, Telcom Kenya had to relay from there. So that building used to have a lot of relay systems. And because PLCs simply replaced the relay systems. And if you read the book that I have recommended, you will see they have even pictures of relay systems. And you will see that there's basically switches but they are very manual and they occupy a very large space, and they get heated so much. So it requires a lot of cooling, and you have to move them. There's a lot of manual operation. And so the General Motors, because they were assembling cars for the demand that existed in the world in the 60s, they were the biggest car assembly manufacturer. They needed to automate their processes. So they built the first PLCs, or they developed the first PLCs to help them replace these relay systems. But today, PLCs are everywhere. They are probably, you'll not even see a relay system. You'll find PLCs from your local bakery all the way to NASA, where there's space exploration going on. PLCs exist all over. So, ladies and gentlemen, as future engineers and as future innovators, you have the power to shape the factories of tomorrow. But you will only do that when you make use of PLCs, and they will help you to solve the real world problems. The truth is, the future of our world is automated. There's no doubt about that. For the last 10 years, you can actually just see how technology has progressed, and it's all around automation. So my question to you is, are you ready to lead the charge in leveraging your knowledge on PLCs to help solve real world problems? If you answer to the affirmative, then we have to dive deeper into the world of PLCs and understand how we can automate industries using these PLCs. So we have to go through the entire semester and study the various components of PLCs that I've told you about. We have to know what is the internal structure or in the internal architecture of these PLCs. What are their input and output devices? Basically, what is the hardware like? Okay, then what is the software like? Then what language do we have to build to be able to control the PLCs or to communicate with the PLCs? Then how do we handle instructions using PLCs, both numerical data instructions and data manipulation instructions? We'll know what those are. How do we use timers and counters to help us in solving some of the problems that we have regarding automating systems? How do we use program control instructions, where you can jump an instruction, or I can interrupt an instruction, or I can use a fault routine to troubleshoot, okay? All these require you to put your mind together and study the PLCs. The recommended class book, which is Programmable Logic Controllers by Petruzella, is very, very illustrative, very self-explanatory, and I encourage you that as we discuss in class, you also read for yourself as we go along. Now, because the book is, I would want to say, uses the American PLCs, that's the last thing I'll end with, you only need the principle. The principle of operation of PLCs remain the same. Manufacturers are different. There's so many manufacturers. The largest manufacturer of PLCs, I think for those who are in the lab, I told you, is Siemens. They make probably 70% of the PLCs in the world. They're closely followed by, of course, Americans would want to have their own. They use what they call the Allen Bradley. And I think the book Petruzella uses the Allen Bradley PLC. But the principle of operation is the same. Allen Bradley used to be called Rockwell Automation. The company used to be called Rockwell Automation before they converted to Allen Bradley. Of course, different countries, if you go to Japan, they want to use their own, so they call it Mitsubishi. The principle of operation remains the same. The manufacturer does his own thing. Germany, also, apart from Siemens, had the Schneider. It's called Schneider, something like that. You have others. You have Omron, Again, these are just manufacturers. We have, if I remember, General Electric. This is also American, General Electric. We have ABB. I'm sure if you go to River Road and you look at some of these most electronic shops, you'll see that not only do they have electrical devices or components, they also have PLCs. So ABB is a common, electrical supplier or electrical equipment supplier, but they also supply PLCs. Okay. There's also Bosch. I think there's Bosch, Hitachi. Let me call Hitachi. I don't know whether this is Hitachi. Sounds Japanese, but there are so many. There are so many. I cannot list all of them here. But our studies are going to be based, because the class book is Alan Bradley. We're going to use Alan Bradley. You will see it has nothing so diverse from Siemens. The principle of operation remains exactly the same. I told you, you will only see that either the symbols that they use change. Okay, it's just like having a car. The principle of operation or of powering a car remains the same, but the manufacturers are different, and what they change is the shape of the bonnet or the shape. They have a different logo, but every functionality still exists and it operates the same way. Okay, the drivetrain, the drivetrain is the same, so you don't have to worry whichever manufacturer we pick. In the lab, I think because we were supplied with a Siemens PLC, it's good to learn it. And so in my notes, I interchangeably use Siemens and Alan Bradley just to show that you're not supposed to restrict yourself really to one type of manufacturer. You can use any as long as you know their symbols. What you cannot do is mix. So if I am already explaining or doing a design using a Siemens PLC, you need to restrict yourself to the data sheet of Siemens, and the symbols and the ladder diagram, the way it is structured, you use Siemens. If it's Alan Bradley, same. Just stick to the same data sheet for that manufacturer and use it, their symbol, for that particular problem. You cannot mix them. If you do, then it causes a lot of confusion. So, ladies and gentlemen, I would want to end here and ask that beginning Monday at 8 a.m., we shall delve deep into the PLCs and look at a proper principle of operation of PLCs and move up all the way to how the architecture is and what the brands are, and then look at some of the softwares that exist before we move on to programming. Thank you very much for listening. If there are any questions, please use this opportunity. We have 5 minutes, just about that, to ask. Any questions from the class? All right, go ahead, Ismail. Oh, okay. Interesting question. When I say that PLCs are rugged, I mean that they are able to operate in very harsh conditions. So it means that they can withstand, things like very hot conditions. They can withstand very dusty conditions or muddy conditions, or conditions that there's got a lot of vibrations going on. So when I say rugged, I simply mean they're very tough. They can operate in any type of industrial environment. And from maybe some of your industrial visits, you can actually see that some of those environments are not fit for human beings. But because PLCs can withstand those kind of environments, we call them, you can characterize a PLC as a very rugged device, or rugged programmable device, because of the fact that you can put it in any type of industrial environment and it will work without maintenance and work for very long durations of time. That's what I mean. I hope that's fine. Oh, all right, good. Any other question? All right, ladies and gentlemen, I know it's evening and maybe you're tired from a long day. I wish you the very best. Marigu, you want to say something?
Hello.
Yes, go ahead.
Yes. Something different a bit. I had a concern with the few other students, the majority